So basically, I'm Dennis and Bertrand. We have a few other team members. If the Zeppelin team members can please stand up so they can introduce themselves really quickly. So I'm Dennis and Bertrand, developer advocate at Zeppelin.
I'm Francisco Giordano. I work on OpenZeppelin in the library.
I'm Martin. I work on communications.
So we may have some other members coming through, but feel free to come up to us and talk to us and ask us questions and all that great stuff. There's plenty of seats up here at the front, good stuff. So I'm gonna have to bend over to advance the slides. So that's a little awkward, but okay. So the title of this talk is Release the ZepKit. That's because it's a new product that we have that's just come out. But we're going to go through upgrade-driven development with ZeppelinOS. So what are we going to talk about? We'll talk about who we are, a little bit about Zeppelin, upgradability, why it's important, how does it work. It's important to demystify some of the aspects of upgradability. EVM packages, what are they, what problem they solve, upgrade-driven development, architecting systems, smart contract systems, ZepKit, which sort of ties it all together, and then hopefully code. Let's see, well, I actually promise. So, about us. By the way, if you want, you can do that right now to start installing ZeppelinOS, so you have it on your system.
And we want to add a dash G, right? Yeah, it makes sense.
Are we doing global right now?
Yeah. I did it both.
Yeah, you did global?
What's
All right. Yeah, placeholder lowercase. So about Zeppelin a little bit. Zeppelin, we build tools for developers. So for developers and operators of secure decentralized systems. So how many of you actually know Zeppelin already? You guys are here, so we should the basics, right? So we help companies secure their systems by performing security audits. We're the creators of OpenZeppelin, a battle-tested framework of reusable smart contracts for Ethereum and other EVM blockchains. This is probably our most famous product. So you probably know of our ERC20s that you sort of see every tutorial ever done about Ethereum using. Safe math is extremely popular. Everybody loves that. Easy to add. We're also the creators of ZeppelinOS, which is kind of the umbrella of what we're talking about here today. It's a framework for creating and managing upgradable smart contracts, and also larger projects. And then ZepKit, the toolkit for developers. So first up, we're going to talk about upgradability. This is sort of like our core part of the offering of ZeppelinOS, and it's a big part of our vision about what the future for developing on Ethereum and smart contract systems is. As I'm sure you all know, of course, we're doing this little thing here. You can't really read that. I'm not going to read the whole thing. The whole point of it is that developing on Ethereum or blockchains, smart contract applications, is really a lot different than regularly developing applications, right? It's something where if you mess up, you've messed up forever. Everybody knows, you lost everybody's money, they all hate you. It can be an awful kind of experience, right? So this is something where, for the first time, we've had this environment of creating software where you get one shot to do it, right? All the features you are going to ever need in the future, you have to build it now. You have to have it absolutely perfect. You can't mess up anything for anything, right? Because you're stuck with it, it's immutable. And that, of course, has been our quote-unquote selling point of blockchain, right? Basically, chance. And what's really unique about that, you can sort of see in the reading up here, is that we're running our code for the first time in a really public adversarial environment, right? So it's not like, oh, you're releasing your iOS game and people can't jump over and collect the coins and now they're pissed at you and you just push out an upgrade, right? You're doing this, the first time you do it is the only time you do it. The biggest part, of course, is that you can never change it. Or can you, right? So ZeppelinOS, actually, we're pioneering upgradable smart contracts and the ability to upgrade. And so we have an example here. I'm going to sort of walk you through the steps on a high level of what's going on, and then we can dig down into a little bit more. Basically here you see a typical regular smart contract. It's called here my wallet. And it has a basic function called initialize. This is actually a special feature of ZeppelinOS. We don't use constructor functions when creating upgradable smart contracts. So for that reason we have a version of constructor functions which is called initialize. Basically it's a function that can only be run once. Right? In this case, we're simply taking the address of an owner and assigning the owner to that address. For creating an instance, when we go into ZeppelinOS, it's as simple as doing ZOS add wallet. Wallet is your contract. ZOS push, which actually pushes your code onto the blockchain, right? So we have the code onto the blockchain. And then ZOS create, which creates an instance of your contract. And this is going to be really important, as I'll explain further on. What we're doing when we're using ZeppelinOS and we're creating upgradable smart contracts is we're deploying our contracts, but we actually, in the end, will deploy a proxy to our contracts. So while you could call your MyWallet contract directly, in this system, you're not calling your MyWallet contract directly. You're calling it through a proxy. But we'll show you more of that in a few minutes. This is your app, version 1, right? It's pretty sweet. You got it out there in the network, version 1. Now, when you modify a contract, right, we are going to add a new function. Right? So this is pretty simple. We're just adding another one, withdraw. The process for upgrading your smart contract, remember, we've already deployed this contract on the network, so it's out there. The process for upgrading is simply ZOS push, which pushes the new source code to the blockchain. We deploy the new source code, and then we do ZOS update, which actually updates the code that we've already pushed out. See some quizzical faces? Good. Hope there's some good questions. So now, the thing that's important to note is when we pushed out this new code, when we updated our code, we have the same address, right? The address that we're calling to doesn't change, because if we change the address, that kind of ruins the whole point, right? We have the same storage state, which is also very critical to understand. The same balance, but we have the new code. And this part is the part that most people go like, what? Because it's the same address, but it's new code, new same state, same balance. So that's some part that's not magic, but we'll get to that. So right now you have MyWallet version 2.0. Right? So you got your new smart contract. You can see that fine, right?
Yeah.
Looks great.
Looks great. Looks great.
Way better.
Does anyone know what car this is? It's actually 1970 Lancia, and there's a real reason why I picked this car in particular, as beautiful as it is. So, how does this upgradability work? Right? Because I've seen some quizzical faces in the audience. Everyone's just like, oh, what do you mean? Transparent proxies. Transparent proxies are the core to upgradability, right? And this is from one of our other presentations. Maybe, yeah. I still love it. Thank you, Mario, but our implementation is in another address, right? And that's key here, right? That means your logic contract is actually somewhere else. And we're using transparent proxies to proxy your contract calls to your logic code. Good. Okay, so how does this work? And this is the part that's very important to understand is not magic. It's a lot simpler than it seems. It sounds really great and really impressive and all that, but it's simple. It's not magic, and that's the number one thing to keep in mind. Because a lot of people, when they start thinking about upgradability, they worry, oh, is this going to significantly increase my code size? Does this significantly increase like the surface area for attack? Does this significantly change how users are going to be able to audit the code that they're using? The answer is, not really. It's a lot simpler than you think. It's not a black box. So, you understand here, the part here to understand is when you use ZeppelinOS to deploy your contract, right? This is your logic. We deploy two pieces. Oh, that's so nice. All right, so first you have your proxy, right? And that is, the address of your proxy is actually the address of your contract, right? So in your case, if you had a contract that people were to call into, that's the address that people are calling to. And here is your logic. That's the code to be executed. That's actually your smart contract that you've written, right? But this proxy is a transparent proxy. And it's very important here. It says keep storage code to be executed, right? What that means is our logic contract is our smart contract, right? But our storage, our memory, where our variables, all of these things that our smart contract accesses, are stored in our proxy. So in this case, contract and proxy, how it works is we keep track of in the proxy the address of the implementation, which is your logic, right? So basically when the logic contract is deployed somewhere, we get the address from that, we tell the proxy, hey, this is our implementation over there. So when we make, so for our logic contract, for our wallet contract that we just had, when we could make a withdrawal call here, our proxy contract transparently proxies this call using the delegate call code to our implementation, right? So actually when you're making a call here, whether this is you yourself in MetaMask, another contract, you never see this proxy, right? You don't even know it's here. As far as you know, your call is going straight to your logic contract.
Is there a gas premium?
A small one, a small one. And how many, do you know exactly how much?
Maybe 700.
Small, right? There is, with all things in mind. But yeah, it's very small. So here we have another wallet implementation, right? That is version 1 of our app, and that's version 2 of our app. What we do when we talk about upgrading, all we do is we point our proxy to the new logic contract, right? So the whole world sees the address of our proxy as the address of our contract, but really our logic contract is back here, and we point the proxy to a new one. So this is the key point here. Your state is stored in your proxy contract, right? When your proxy proxies on a call to the logic implementation, is doing so in the context of the proxy contract, right? So that means all the storage is being kept in the proxy contract, right? So let me give you an example. If you were to deploy an ERC20 contract, right? Everyone's familiar with what an ERC20 is? Raise hands, how many people know what an ERC20 token is? All right, okay. It's a token, basically a fancy way to raise a lot of money and then disappear. But it's a token, and it is a relatively simple implementation. We have a special audited version of it, which is practically what everybody in the world uses. But basically, when you create a new instance of an ERC20 token, you would say, okay, this is the name of my token. It's called Denison's Awesome Token. This is the symbol of your token, which is like DAT. Denison's Awesome Token. Then you say, there's 100 million of them. Here are the initial balances, etc., right? So I create that token. I create that ERC20. I deploy it to the network. Now, if you call that contract and you say, hey, what's the name of this token? It returns to you Denison's Awesome Token, right? Because the contract is storing that value in the contract, right? That's what you would expect, right? That's how you normally would interact with it. If you were to mint a token, and okay, let's mint myself 1 million tokens, the balances of those tokens are stored in the memory and the storage of the ERC20 contract, right? When you're calling it directly. What's happening here is different, right? Because when we delegate call through our proxy contract, what happens is that balance, right, isn't stored in the contract, it's stored in the proxy because we are accessing the functions in the contract in the context of this. People sort of get that? It starts to make sense?
That is something that, like, the delegate call generates that behind the
Yeah, exactly.
When you're setting in the delegate call context, it also sets in the, well, it sets in the proxy storage, right?
Right.
Okay.
Right? So when the proxy calls this logic contract, and so let's say you say, okay, what's Denison's balance of the tokens? right? Delegate call here to the function, what is the balance of Denison's token? Well, Denison's token is in the storage, but the storage is over here. And it says, okay, Denison's token has 10,000 tokens or something like that, right? So even if this contract itself were to be initialized and say, okay, actually I'm Raymond's token and Raymond Denison has no tokens, right? When we call it through the proxy, it's using the storage values here, right? Oops.
I actually have a few questions, sorry.
Sure, no.
First thing is, how much does it affect the speed? The second thing, is it possible to destroy the previous contract?
Ooh, that's good.
And, what was the third one? Yeah, speed, or something else. Anyways, when I remember. Is it possible to self-destruct the...
Right. So let's start with the first one. The first one's speed. No, it doesn't impact the speed because the transactions all have to be finalized within the block, right? Anyway, so you're waiting the same amount of time as you would normally. The second question, in terms of if you were to destroy which one?
The previous one. Let's say you found out it was vulnerable.
Right. So in that case, things can get tricky, and maybe you're going to want to correct me on that. But if you destroy this contract, right? Now, there's two ways you can destroy this contract, and this I believe is what happened during the parity wallet hack. But there's two ways, right? So if this contract has a function on it called, kill, and it kills the contract, right? If I call this contract directly, not through the proxy, or this one, because it's pointing to this one, right? If I call this contract directly and kill this, the proxy is no longer pointing to anything, right? Correct? Right? So if I call this one directly, you kill this, and the proxy is no longer pointing to that. So if this proxy can't be told to point somewhere else,
it's offline.
right?
The last, sorry. So where's the proxy stored exactly?
Where's the proxy stored?
Right.
Well, the proxy looks like any other contract in the blockchain, right? So it has its own storage, it has its own memory slots. It looks like any other contract on the blockchain.
It's important to say that since self-destruct is dangerous in this context, the ZeppelinOS tool will try to prevent you from deploying a self-destructible implementation contract.
Yeah, because, and correct me again if I'm wrong on this, if you were to call through your proxy somewhere that somehow calls self-destruct, you would end up destroying your proxy, right? So if you so if you destroy your proxy, then you're really effed, because there's nothing else to point to anything, right? Like this address is what everything is pointing to, and now this contract is there. Right? So yeah, don't do it.
Can't you do like upgradable contracts just plain solidity?
How do you mean? I mean, this is plain solidity.
Yeah, I mean without Zeppelin.
Sure. You could definitely build this yourself, right? You could definitely say, okay, I'm writing my own proxy contract. You could do that. What ZeppelinOS gives you, which you might not have on your own, I mean, you could go build, like Denison's OS.
What are the other
The advantages of it. So the ZeppelinOS system, one of the things it does for you is it keeps track of all these codes, all your proxies, all your implementations. And I wasn't necessarily going to, maybe I'll cover it in EVM packages later, but yeah, let me get back to that in EVM packages, because there's an advantage that you have on top of that down the line when we get to code sharing.
Can you explain like the ownership situation with these? Like, is the proxy the owner of the implementation contracts? Do you have like a management feature, or can you have like owner like management feature in a proxy? Because obviously it's like if the proxy is compromised, you could just route it to some other contract.
Right. So half of that question I'm going to get to later in the slides. And the first one was who owns this?
Yeah.
Well, no one owns this, right?
So it's not an owner.
Well, it's not important, right? Because the owner is something that you're storing in the state of the contract, right? So in this case, that is being stored here. So, like, if this were an ERC20 contract and I were to deploy it, right, and then I have a proxy to it, but I directly call this and say, hey, initialize this thing, you're going to be like this and that.
Yeah.
Doesn't matter, because when you proxy call into it, it's going to be operating in the context of the proxy. So it's sort of like free code.
Yeah.
I mean, you certainly could like maybe come up with something really complicated that wouldn't work, but in general, it should be fine. All right, so next part is EVM packages, which is sharing code at the bytecode level. Going back to basically the same thing that we had a second ago, there's something interesting, maybe some of you have noticed that, beyond the idea of upgradability, right? Because if we have a proxy that's pointing to our logic contract, right? And we can just point the proxy anywhere, and it doesn't actually change the nature of the contract as it's deployed. We have another team member just showed up. Means we can make lots of proxies to the same code, right? Because if the state is stored inside the proxy, right, then it doesn't matter how many proxies are calling the same piece of code, right? They're all keeping their state themselves, locally, right? So for me, this ERC20 is Denison's ERC20. It's also Jack's ERC20. It's also Rachel's ERC20, right? Because the state is stored here. It's just the logic implementation that's being held in the code. So each proxy keeps its own separate state. It's not manageable. Deploy it once, use it repeatedly. So this is what we're calling an ERC20, well, an EVM package, right? This is, here you have a version 1, here you have a version 2. And this is what ZeppelinOS does for you that you could certainly roll your own if you wanted, but ZeppelinOS gives you an advantage. You can bundle this up and you can handle versioning within ZeppelinOS. Right? So you create the one version of your contract. ZeppelinOS has a JSON object that keeps track and says, okay, this is version 1 of our contract. And then you upgrade it. Now you have version 2, right? But what if version 2 you actually really mess something up, right? You can make an improvement that totally borks your software. Well, it would be really nice if you could easily switch back to version 1, right? So EVM packages are collections of versions of code of your project. Right? And that's what ZeppelinOS gives you, is the ability to manage that in an easy way. Right? You could certainly write proxy implementations on your own. Right? The delegate call isn't something that Zeppelin owns in particular. But ZeppelinOS gives you the framework and a lot more good stuff to allow you to do it in an organized way. So, what problem are we solving with EVM packages? Right? Let me go back here for a second. What is, if there's an immediate benefit once we have these proxies calling into the same function. Can anyone think of it off the top of their head, just looking at it?
What was the question?
So there's a really obvious benefit here that once I tell you, you're like, so there's a really obvious benefit to deploying your code once and then just deploying proxies to it in the future.
I mean, that's just logic, and that's the data.
Yes, that's true. That's also really
The
great.
gas costs?
The gas costs, right? Right now, Ethereum's pretty expensive to deploy contracts on, right? Maybe if you're deploying an ERC20, you're like, okay, I'll pay the $20 now to deploy my contract and be done with it. But what if your contract deploys, what if you have a contract that's a factory function that deploys more contracts, right? Let's say you have a contract that deploys an ERC20 for every new user, right? That can get really expensive really fast, right? Like if you really go hit it viral, I mean, imagine if each CryptoKitty itself was its own contract and you had to deploy it and it cost $20 per user to deploy, right? That's really expensive. So the number one, the first thing right off is you get cost savings because you only have to deploy all your logic. I mean, if you have a huge contract, you only have to deploy that once. After that, all you deploy to proxies. And we've made sure that these are really lightweight, small contracts. The difference in cost can be enormous depending on how big your contract is and how often you're deploying it. Right? So another thing is, in the ZeppelinOS system, you can do it from the command line, but we also have the app manager itself as a contract. So you can call this programmatically. So your contracts can deploy upgradable contracts and link to other contracts, right? So depending on what you're building, this can save you all the money in the world. Right? So that's the first one. The other one is security, right? When we're deploying EVM packages, sorry, not EVM packages, when we're deploying ERC20s, or when most people are doing it, right? You're copying the code from GitHub, you're extending from the code, you're maybe say, oh, you want your own sort of feature involved inside your ERC20, so you go in and you change something. This is a real opportunity for bugs, right? Like, this is a real opportunity for you to bork something without even knowing it. I mean, something I do all the time is I think I'm typing in another window, and really I'm still in like VS Code, and I'm adding all sorts of nonsense to it, and being like, oh, where is it? I can't type it yet, right? So it's really easy for you to mess up code. This really simplifies that. And actually, we're building a mechanism that also adds another layer to this to allow for vouching and verifying the code. Right? So down the line, we're looking at ways to be able to ensure the security of this. Right? Now you can create composable smart contracts. Right now, a lot of the times what you do, let's say if you were to, okay, so during the like ICO boom, a lot of what we saw was people were creating ERC20 contracts. Right? And they're saying, okay, now I have my ERC20, but I need to sell my ERC20. Right? So you get one ERC20 token for every one Ether that you deposit. And we're going to write a function inside our ERC20 that takes your Ether and now mints you an ERC20 token. Right? But that's not really great code hygiene. Because you're actually mixing concerns. You're creating an ERC20 contract that is selling itself. Right? Like you have the logic for handling keeping track of people's balances. And then you have the logic for handling selling tokens. Or maybe distributing some sort of other benefits, and people commingle these, right? And that's a huge opportunity. Right? When you say ERC20, Denison's great token is ERC20, and you're inheriting the code, you're building on top of that, sometimes you're mixing concerns. These things should be separate, right? And that's important because once you have code that's separate, it's a lot easier to test. It's a lot easier to test, it's a lot easier to keep track of, it's a lot easier, in this case also, to be modular, right? Because if you're building ERC20 and you have a crowd sale as an example, crowd sale should be separate, right? That's doing something separate, that is a separate attack vector, right? That surface area is very different. Our ERC audited smart contracts in the Open Zeppelin library are secure. Right? But as soon as you just inherit from it and you start playing around with it, that security goes out the window. Right? So yeah.
How do you do to ensure that every contract deployed to the network is being audited flexibly? Like when you are in every line of code that everybody wants to deploy via ZeppelinOS, are you auditing?
No.
Okay.
No. So one of the things that we've done is we have deployed the popular contracts, ERC20, ERC721, we deploy that as an EVM package,
Okay.
right?
So they use that in order to build.
Exactly. Exactly. So in that case, you're doing composition, right? So your contract is creating, you create a proxy, and you're dealing with it directly like that, but you're not inheriting the code, right? You're not like building it with a big Franken code monster and then like adding the features all in. But we are not auditing, like if you create something with ZeppelinOS, let's be clear, we're not auditing it, right? That's a separate business. If you do something and lose everybody's money, that's on you. Right? Don't be like Denison said, we all audit everything, right? No, that's not a feature of ZeppelinOS. Another cool thing that'll be more important that we believe you'll see more of is private code libraries, right? If you're working on a big team, maybe you're in a consortium of some sort, private network, and you are a team where you have the developers working very separately, maybe you're going to create a library of contracts that are approved, right? You can only use JP Morgan Coin ERC20. They're not involved in this, I just said their name. Right? Maybe you can only use certain approved implementations of code for your project, right? Also, you can now create parts of, if let's say you're working on a project and you find yourself building something over and over again. Like, maybe let's give an example. Signature recovery, right? You're doing that all the time. You can take that code, right? You can abstract it, and you can create a singular EVM package from it. Now, in the future, all you have to ever do is you just link to it. You don't have to redeploy it. You don't have to do any of that, right? So you can create code blocks that you can then build your software.
What does it look like when you use an
No, so what you do is, yeah, you essentially, we call it linking, right? It's a command called ZOS-link. And what happens, actually, I don't go through that too much here, so I'll just tell you. Basically, when you create an EVM package, let's say you create a piece of code and you decide, okay, this is a standalone project, it does a specific thing, and
It has a unique name, right? When I deploy it,
well, no, it doesn't have to have a unique name, it just has to have a unique address, which it'll always have anyway. But I have a great tutorial on the Zeppelin website about how to make a linked list as an EVM package. And that's a really great use case. Actually, LivePeer has an EVM package as well, which is a double linked list, right? We know our data structures and solidity are particularly weak, so you could do something like a linked list. You deploy it, now you always just link to it, and then it's simply the same way as you would call a contract inside your code, right? You would say, address, Denison's contract at this address, and then it would just be Denison's contract dot whatever the function name is, and you're done, right? Really easy, really easy. And you can be as descriptive as you want with the code, which is helpful. Long term, we really see this as becoming a kind of like NPM repository for code, right? So one of the things that you can do with ZeppelinOS when you create an EVM package is you can publish it, right? When you publish it, ZeppelinOS wraps up everything that you need to run the project.
that's what I meant by the unique name. Like when you publish a package.
Oh, it doesn't have to be, well, so there's two aspects to it, right? When you publish a package, you can publish it and then you can like email me and be like, yo bro, here it is. And that, it doesn't really have to be unique, right? Like everything's by address in the Ethereum, so it's not like if you call it Denison, you'll be able to call it Denison again. But built into ZeppelinOS is the ability to publish directly to NPM, right? So when you publish to NPM, yeah, you're going to have a unique name, it's going to have to be lowercase, you're going to have to have an NPM account. But what that means is that if you go through the tutorial, you can create the linked list, you can publish to NPM, right? Now you have a linked list on NPM. Anyone else in the room can go download, you do ZOS-link, Denison, well, I forget the name of that, I think it's like Denison. It's either like crazy rabbit or something like that, I don't know. But like whatever my name is, linked list, right? And ZOS goes and downloads all of it from NPM, puts it in your project, it instantly becomes accessible. You have the code inside your project, but then when you go to deploy, you're linking to the instance of it that's on the chain deployed already. Okay, so you don't have to do that. Alright, so upgrade-driven development. So what are we talking about here? This is a little bit of a work in progress, and this is talking about the new way that as developers we should be thinking about creating smart contract code if we're creating upgradable smart contracts, right? Upgradable projects. Because it goes a lot beyond saying, hey, yeah, my wallet version 1 sucks, so wallet version 2. Right? So if applications can be upgraded, and this gets to your point a little bit earlier, who decides when and what to upgrade? Right? And only one person asks this question. Normally that's what people freak out about. So with ZeppelinOS, and if you were rolling your own, if you want to do it like artisanal, upgradability can have as much or as little governance as necessary or as desired. Right? So it's important to also remember we are not in control of your ZeppelinOS project. Right? We can't upgrade you. You can't force upgrade anyway. Right? You're at version 1.0. Sweet. You're at version 2.0. Sweeter, right? The reason why I picked this car, the Lancia, now I forget the name of the model. This was a horrible car, right? This window, this driver's seat, was so inclined and so tight that you couldn't get out of it by yourself, right? So like once you got in, somebody had to pull you out of it. Right? There was so little insulation between the engine and the driver's seat, it was impossible to hear the person next to you. Right? And it had a luggage compartment that was like this big. Right? It was a terrible car. Right? But of course the guys that made this car thought it was the future of the car. But this was way more useful. Way more useful. And cheaper. So if your users wake up one day and you had smart contract version 1.0, and now you've given them smart contract version 2.0 because you are convinced is the new big thing, and they're surprised, they may freak out, right? I mean, I would freak out, right? If you woke up and someone's just like, hey, we gave you a new wallet, you know, we went into your bank account, we stacked your bills a little differently, you'd be pissed, right? So, governance, and this is part of the idea of thinking of upgrade-driven development. It's important for us when we're building upgradable smart contracts to start thinking about who upgrades, when do you upgrade, what is the threshold for getting someone to upgrade? Because it's not a monolithic process. It's not just the matter of, you can certainly build something where you say, I'm Edison, I know what you need anyway, so you know it's up to me. I have my private key written down on my computer, and like, yeah, I click enter, everybody's upgraded, take it or leave it, right? You can certainly do that. But now you can think of new ways, and we don't build this for you. This is something that you can build yourself, and we're looking at people who are building EVM packages to actually help manage this process. But you can have a multi-sig requiring, let's say, if you have, you know, if you've ever looked at the CryptoKitties contract, you'll see that major functions are handled by their 4 or 5 C-level executives, and if they all agree on something, they can change something fundamental. Certainly you know that minting a rare kitty is something they get to do whenever they want, right? You can have an application where there's certain functionality where the upgradability is just based on the C-level administrators, right? Like maybe you have a game and yeah, you and the CMO want to have the right to be able to decide, you know what, these cats, they're not breeding fast enough, nobody's using them, we got to double how fast they breed, right? Maybe that's in your mindset of like, that's what is our responsibility. Maybe you have a DAO. Right? Maybe you have some sort of larger organization that's using upgradability, and you have the DAO that manages that, right? So you can certainly imagine any sort of crazy combination of like requirements necessary, some sort of token voting, or like liquid this, or bonding, whatever, right? You can imagine that. You get up a vote, right? 51%. We're all voting with tokens. Once we hit 51%, we're upgrading. You're on the vote, or you're not on the vote, whatever. Right? And that controls the proxy, right? So that is how you can set up that level of like granular upgradability. You can say, okay, everybody's got this car, or some people have that car, or we're on to this car. Something else that you can do, and this is also another really kind of mind-crazy part about like the idea of upgrade-driven development, is that we are finally making applications that users trust, right? And I'm going to use MakerDAO as a really quick example because they're awesome, right? Everyone trusts them, basically, right? It's kind of crazy. They have a lot of ether in there, like 2% of all the ether. We're like, ah! Right? So we have applications that people trust, but they trust in a different way, right? When we're using Instagram, for example, we simply trust Instagram in a very binary way. You either trust it or you don't. You either trust Facebook or you don't. But now we can build software where we have granular trust levels. Right? We no longer have to have a monolithic trust, right? I can trust Instagram with my like hot dog pictures, but maybe I don't trust Instagram with my identity, or maybe I don't trust them with something else, right? So you can start to build software with granular trust levels. So in this case, that includes the idea of upgradability, right? Maybe your contract for fixing bugs, which controls the upgrading of the proxy, can only do game mechanics. Right? Maybe that is, again, a C-level thing. Hey, we rolled out an update, doesn't really work that great. Let's just fix it before the users wake up. Right? Fine. Maybe that's their right, and maybe that's reasonable to do. You don't need everyone to vote on it. Right? If people voted on like an Instagram interface, that would be awful. Right? Contract dev vote. Maybe something for the game interface, right? So let's say in the beginning, you have, I don't know, your cars, right? It's a car game or something like that. You have 2 interfaces. You can allow a decentralized exchange to like sell your car, or you allow your decentralized exchange to, I don't know, lock it up or something like that, right? But maybe down the line you want to improve that. Maybe you want, like you're like Decentraland, and you want like to be able to sell mortgages for the property, or maybe you want people allowed to repurpose your car. Maybe you want people to like rent your car out while you're gone, something like that, right? So maybe the interface of your application expands over time. Right? And maybe that's something that the developers get to decide on. Right? And maybe the users know that they can trust the game mechanics to the executives of the company. Maybe they trust the developers in a different way for the game interface. right? Certainly they're not like, okay, I don't know how to write Instagram, so I have at it, right? That's your thing. But then maybe not upgradable is the user tokens, right? I have my money in your game. I put all my time and mana into it, and I get my decentraland property, right? Maybe I trust you with the game mechanics. Maybe I trust the developers with the interface, but maybe I don't trust any of you with my land, right? Or my mana or my tokens, right? So now when we're building applications, we can think about, okay, how are we going to architect this in the beginning so that it can grow in an organic way that can service users' needs and trust levels and our needs as a company, because come on, let's be honest, it's ridiculous to think that you're going to launch an application today that's going to be just as useful for the next 1,000 years, right? Or however long Ethereum runs for, right? But maybe it's 1,000 years, right? Like your crap ERC20 token will maybe still be there in the year 3019. You'll be like, oh, we should have upgraded now. Right? Maybe that's the future, right? Instead of version 1 of your app and version 2 of your app, maybe the users decide what their app looks like, right? Maybe you can architect an application where users can use, okay, for my mortgage provider for my Decentraland, I want to use MakerDAO system. I want to use DAI, and someone else is like, no, I love centralization and companies will use Gemini's like US dollar coin, right? Maybe people in the future, when they're using their software, maybe we can build software that allows them to build the software themselves, right? To be part of the process of building the software themselves, right? And upgradeability, EVM packages, this sort of not magic lets you do that, lets you build these type of things. So in this case, it's like, you know, that's maybe what it would look like in the future, which is pretty sweet, right? It's a lot better than the other. So yeah, trust does not need to be monolithic. You don't have to have your users trust you absolutely in a binary regard anymore. Yeah, a little bit more. Upgrade-driven development, it's an iterative process, right? It's a lot like test-driven development where you create a test, break it, pass it, create another test, break it, pass it. But you create a test, break it, pass it, you deploy it. Users are a whole different world, right? Like this is the first, you know, it's one thing when you create software, say, hey, everybody, this is just for like, you know, Windows, so, you know, it's just that, right? You have some sort of sense of control over the environment, your runtime environment, right? Here you don't have that, right? Like once you get out into the public, heck, you don't know what's going to happen. It's an adversarial environment. MakerDAO certainly has no idea of all the possibilities they can build with their software, right? But they know they have to get it right. They know they have the ability to fix it. I don't know if you can actually fix anything right now, but I'm not going to get into that, right? It's also the understanding the shape of the networks we build are fluid and require robust, non-fragile software, right? You build CryptoKitties today and you want to build a company on it and you want it to be here 5 years from now, you're going to have like crypto doggies too, or dragons, or whatever, you know, like it has to be something that's non-fragile software. Software can be abstracted into areas of upgradability, responsibility, and governance. And that's what we were talking about before, right? You have an ERC20 token that takes care of itself as a token. You have a contract that takes care of selling it, right? These things aren't the same thing. It's not the same purpose, right? They shouldn't be commingled. Well, the upgradability for those shouldn't be commingled either, right? Like the process of selling the token is a hell of a lot less important to me than keeping my token secure and safe in the first place. Right? So the final piece is ZepKit. This is our newest product offering, and it's actually for developers. It's basically takes everything that we have and wraps it up in one sort of package. And this is a way, one of the things that we notice with developers is that there are too many choices for smart contract development, right? Like when you sit down to start your app, if your app is just wallet, right, like set wallet, the amount of boilerplate code that you have to do before you get there, before you deploy, is kind of crazy. Right? Like the amount of effort they have to go through is a little bit too much. So we created ZepKit, which wraps in all the basic things that you need to get started, right? We have a React app, we have ZeppelinOS built in, we have the Open Zeppelin EVM package already installed, we have Infura with our own special, token, API token, so you can immediately start deploying right away. We have everything that you need to like get started in one thing, right? So what we're trying to do with this product, And this is a real iterative process, so we're really interested in your feedback. Is we're trying to create something that really lubricates that process of getting onto the mainnet, right? It's trying to accelerate your development. Yeah, I already told you all of that. So, we are hiring. Oh, question?
Any plans for supporting Vue?
That's something I've personally been interested in. So I've just recently started looking at Vue. I'm going to pass it on. We went with React because, of course, everyone's like, oh, React. I'm personally interested in Vue, so yeah, that's definitely like in the mindset. It's definitely something we're thinking about.
I just hate Redux, you know?
So I'm a Redux lover, but I've been hearing more and more people are just like, oh, Redux. I mean, there's a lot of boilerplate, it's true. But yeah, that is definitely.
API though. Comcast API in the way it's React.
Oh, okay.
It's supposed to get rid of the reliance.
Oh, that's right. I haven't checked that out yet. But I'm definitely interested in that as well, so I relate that to the team. And yeah, we'll get on that. So we're also hiring, so think about that. Join our forum where we have all our lovely activity and discussions. That's where you can like find a lot of information about what's going on and what we're doing, get more information, blah blah blah. You can Twitter me. That sounded weird. You can contact me. So, any questions? I don't know how long I talked for actually. What time is it? That's 8. That's like an hour. That's good.
You started, oh no, you started like 7.
Yeah, it's like 7. Was it like too fast? It's a lot of knowledge. Okay, questions. I know you have some questions. I know I took some along the way, so maybe I depleted your question stack. Does it kind of make sense? Does anyone feel like, oh, it's magic, I don't get it? Right? It's because it's definitely not magic. Once you understand it, you can build some crazy shit.
Question.
Yeah.
I want to check out the code on Etherscan. I guess I probably see the token, get the proxy, load it up in Etherscan. What do I see now?
So actually, someone just deployed it on. There's a thread internally where we've been working on that. I think that now the code, at least some of the code is verified. So you should be able to see that already. Don't entirely quote me on it because I just like grazed over the thread. But that was something that we've been working on that was important to us as well. So,
But yeah, you are going to see the proxy at the address. You're going to see the variable that says like implementation or something that is pointing to the actual code. Right now, Etherscan doesn't have like a specific interface for these upgradable proxies, but we would like it to. And it's something that we can work on.
Have you spoken to them about it yet?
Maybe, but I'm not sure.
Yes.
Yeah.
Yes. And we also have the verify command on the source plate.
oh, that's right. That's right. Yes. We do have that.
There's a verify command on the source plate tool, so you can verify your contract against Etherscan and Etherscan, I think.
Yeah. In progress, but yeah, it's happening. It's very important.
Yeah, how many major versions of ZeppelinOS have there been, and when's the next one?
So that's a really great question. We are on the major version 2 now. We launched the first one in Buenos Aires last May.
No,
Previous May. We're version 2. We've been doing minor releases pretty quickly. So we've had 2 minor releases in maybe 3 or 4 weeks. I think there's another release coming out next week. Don't quote me on that, I won't promise. So I think 2.2.3 is coming pretty quickly. So we're iterating on this really fast. On the forum, we get a lot of feedback. On Telegram, we get feedback. Really, like, developers come to us and say, hey, this doesn't work, or I want to do this, or why do I have to do that? And, we work pretty hard to make that something that is a dynamic process.
Okay, and for ZepKit, I know there's some issues right now between Truffle and Web3. Do you guys handle that in the Zeppelin kit as well?
Yeah, and actually maybe I'll do like a couple minutes of ZepKit to show you, and maybe there won't be any compatibility issues, because there were at ETH Denver, because like Web3 had changed like literally 6 hours before we did our demo. People are like, why did it work? And we're like, it worked this morning. And it was like 11 in the morning, right? But I believe those have been solved. It's working on Solidity 5, Truffle 5. So that should be solved. You might still run into issues if you still have an old version of Truffle installed. So generally we sort of advise like clean out like the old version of Truffle. Web3, like chasing Web3 is kind of like a moving target.
Yeah, I mean, I think what's going to be great about having it all in one repo is eventually when there are these compatibility issues, they're there as opposed to spread across 3 different repos, all linked within one issue or 2 issues or 3 issues.
Something else that we're talking about is support for alternatives to Truffle. So in the future, we would like that you're not just tied into that. You can use whatever else works for you.
Are you stuck with the same version number or Solidity version on your contract?
No, you're not. So I'm assuming what you mean is if Solidity upgraded. Right. Right, so as long as you've already deployed your contracts, right, those will continue to operate how you already expect. You could potentially run into issues if you're going to like recompile everything and redeploy everything, and then you have different versions of Solidity at the same time. That's something that, I think, my opinion, maybe using alternatives to Truffle might like solve the ability to like, compile contracts based on like the fragment version independently. But yeah, it could be an issue, but if it's already deployed, it should be fine.
Is ZepKit like working with the eWasm thing?
Not yet. So ZepKit we released the week of ETH Denver, so it's a really fresh product. I mean, like internally, our boards of like our Pinterest inspiration boards. We have a lot of things that we want to build into it, so we're definitely like thinking forward to the future. At the moment, it's a little bit vanilla, like it's what you would expect to like get going for if you were like a hackathon and you wanted to like get going with your like Solidity React project right now. It's kind of out of the box like that. But yeah, customization is something that we will have more done on.
Can you chain proxies? Remember there's a reason.
You mean like proxy to a proxy to a proxy?
Yeah.
I don't think you can do it more than twice. I'm not the total expert on that. I think my gut feeling is no, and that's because I think the context would not change. It would always be operating in the context of either maybe the first proxy you went through or the last one. I'm not sure. So I've thought about crazy ideas like that as well. I like you're like, yeah, there could be like proxy for another thing. Certainly you could like build something sort of like, in my mind I was thinking like maybe we could like build an old-fashioned calculator just like proxies and like that. Try it.
I was thinking maybe like you do collaborative projects, you share some kind of, you have your own proxy pointing to your own stuff and some collaborative situation. I don't know, totally spitballing.
I mean, there's definitely an opportunity to build cool things. One of my own personal pet projects is I'm curious about building proxies that keep track of what goes through them, sort of like metrics. On the main network, of course, that becomes very expensive if you're paying for all these additional things. Once you're talking about other blockchains or private networks, you can start to do really crazy things, and you can certainly keep track of all your calls or something cool like that.
Right. How do the balances get rerouted from the smart contract back to the proxy?
So they never leave the proxy, right? So the way when the code is executed on chain, what happens is that it's always executing the logic code in this context of the proxy, right? So when the logic code says upgrade or not upgrade, change variable at memory position 0 from 1 to 4, right? Memory position 0 is actually in the context of the proxy. So it's the proxy's memory position 0. And this is important because in upgradeability, if you go through the documentation for more details, there are some things that you have to keep in mind, right? So if you have your storage slots in your proxy context, So storage slot 1, storage slot 2, storage 8, etc. Right? You can't, when you upgrade, you cannot change the layout of your storage. Right? So you can't say contract 1, my first declared variable is a string, my second declared variable is an integer. Right? And then you upgrade and you say, okay, the first declared variable is an integer and the second declared variable is a string. No, you can't do that. Because you're calling in the context of this, what you've done is you just flipped.
I'm trying to understand, like when you upgrade, like how do you move your balance from the previous contract to the new contract?
Well, you don't have to because it never moves in the first place, right? So
It's with the proxy, you say.
right, it's with the proxy. So if in this address, in this contract I have, ignore this part because that's about what the proxy calls. If I say string name, and I have a function over here, set name, and I go set name to Denison, the name is stored in memory slot 0 of the proxy, right? Denison. When I point down to here, right, and I have some other functions, memory position 0 of the proxy still says Denison, right? So just because I pointed to a new contract, no difference. No difference. Yes, me. I'm like slowly losing it.